Everybody, I'm Laura. I'm a front-end developer at Swedbank. But today I want to talk about music, how we can code music. And I already noticed that people get really confused with this term, and despite that we know what is music, we know what is programming. But when it's combined, we become unsure what we are talking about. So to put it simple, I'm going to talk about coding, where as an output we can generate sound, and with which one we can create music. It's pretty simple as this. And a natural question might pop up into your head. So does this talk for musicians or for programmers? Or we need to have both kind of skill sets to start doing something with music programming? And before answering that, I'm always very keen to know about the audience. How many musicians do we have here who are playing with some sort of instruments, singing, or creating music? Perfect. Easier question. How many programmers do we have here? A lot of us. Perfect. To have any of these knowledges, this is an advantage for sure. But honestly, to start doing something with music programming, you do not need any of that. And I would say that can be as a perfect entry point to start doing something with either musical or programming sides. Let's dive into 1843. 1843. This is the year when music programming as an idea was already introduced. And as you see, we did not have the computers as we understand them today. But despite that, Ada Lovelace, she described in her works that computing engine can be as a perfect tool to create precise and scientific music. That means this topic is known for a while. And no surprise is that nowadays we have different ways how we can create music with the code. And today I want to talk about two different programming languages for that. The first one, our universal programming language, JavaScript. How many of you know JavaScript? Of course, almost everyone. I'm going to show you two ways how we can use JavaScript, how we can do live coding, how we can create music and change that on the fly, and how can we use that for our web applications, how we can create music there. And then we will talk about totally different programming language, a language which was specially created for music programming. It is Sonic Pi. And I'm going to show you as well how can we do live coding and what would be the differences. Let's start with JavaScript. And for that, we need to meet Jibber. Jibber is a browser-based environment which enables us to create audiovisual art. And today I'm going to focus only on audio part. Nothing to download is needed. A simple go to jibber.cc, and I'm going to show you that. Here's Jibber. On your left, you can find tutorials, demos, and useful information, and full right is for coding. Let's start with something simple. Let's start with Hello World application, right? But as you imagine, we will not see Hello World as we get used to that. In music programming, we have the analogy of this, which is first beep sound. Let's do that. And I'm going to use periodical sounds, which are known as oscillators, and there are different kinds of oscillators. One of the most common, there are sines. So what I'm doing here, I'm simply creating object of sine. And in Jibber, I can even emit new keywords. So only with this line, I'm creating the object of sine. And at this moment, I can run my program. We have first beautiful sound, right? And be aware that since it is periodical sound, I need to stop it manually as well. So I'm running and stopping it manually. Perfect. How can we change that? How can we change that in order to create some melody? For that, we need just a bit to look into physics side, because what we are trying to change that, what do we want to modify here? Physics saying that sound is vibrations which travel through some sort of the material. That material is usually just an air. That means in order to change the sound, we actually want to change vibrations. How can we do that? There are two ways. We can change the frequency. That means how often molecules are moving in vibrations. And with that, we can get different pitches. With the high frequency, we can get high-pitched sound. With the low frequency, we can get low-pitched sounds. Another option, we can change the amplitude, how far molecules are moving in vibrations. And with that, we can get a different volume. So we can get quieter and louder sounds. keep an eye that there is the range in which we need to modify in hertz and decibels, because our human ears have some limitations. Let's try to apply these options in Jibber. How can we do that? There are a few ways. The first one, we can provide this value during initialization of this object. That's why now I'm saying that the frequency here should be, for example, 600. And we hear different sound. If I would change 600 to 400, how many of you think that we will get a lower pitch? Who thinks that we will get a higher pitch? Let's try. Yeah, lower pitch, because we wrote lower frequency. Another way, we can actually move this object to the variable, for example, as here. And later on, I can reach the property frequency, and I can modify that as well. And at this point, I need to tell you one interesting thing in Jibber. If I'm using one letter variable as s, and I am rerunning my object creation with different parameters, observe what happens. But if I would change my one letter variable to not one letter variable, why? Why did we hear now all sounds playing at the same time? That's a mystery. And I'm not joking here. This is really what documentation says, that the reason for this remains mysterious, but are promised to be revealed. Let's be aware of this, and we can move forward, because I promise to you, we can change frequency and amplitude as well. Let's do that. And it's pretty in similar way. We can do that during initialization. Just here, we are using not the default measures, which are decibels for amplitude, but we are using Jibber measures, where the quarter would be as a default sound. So let's have something more than quarter, and later on, something less. We hear the difference. And with these basics, how can we change amplitude and frequency? We can go to the next level, literally, because oscillators assign their pretty low-level element in Jibber, and there are more advanced ones which are acting more as instrument-likes. There are different synthesizers, and I'm going to use one of them. They're called synth. So here now, I'm creating the instrument. When I'm running, I do not hear nothing, because we are creating the instrument. And later on, we can say what kind of note do I want to play with that. Let's have same 600 note. It's a bit different sound. There are different kinds of synthesizers which we can use. Mono here. And there is one special synthesizer, it's called sound font. Sound font, it is sample-based synthesizer. That's why I need to say what kind of sample-based do I want to have that. Let's have something classical. Thank you. So this is how we can start to play some sort of the melodies. Just to play with hertz, it's pretty tough, because you do not know by heart what kind of note it is. And there is an easier way to do that, because in musical world, we can express notes by letters. For those who are not familiar, this is the correlation between hertz and letters. That means, instead of saying 440, I can say that it is a note in 4th octave. And we can do that in Jibber as well, and that is working with all synthesizers, except sample-based. That's why I'm coming back to the synth now. I'm taking bleep this time. I will add a bit more volume. And let's have 440. And I can change that to A4 as I mentioned. We have the same thing. Let's talk about another optimization. So far I'm using only one note. And I change that and I need to run my program. There is a more efficient way to do that. We can provide the list of notes and to play that. For that I need to use, instead of note, I need to say play. And now I need to say what kind of notes do I want to play that. Let's have, for example, 3 times E3 note. But also I need to provide another list to say how long each of notes should take. Let's have the quarter and then something else. By default, when I'm gonna run this play, I'm gonna get even the repetition of these notes. And what do I mean? Okay, what did we have here? I wrote more notes, more times, and simply ran the program. We heard the difference, right? Then I moved my list of notes and list of times to different variables because I wanted to reuse them for another instrument, for mono now. And the last part, I introduced one new element in Jibber, drums. Drums are one of the most popular. You always use drums somehow. And for their creation, we need to provide the string of special character, which indicates what kind of drums you want to have. We can have open, close, hi-hats, kicks, snares. And you as well need to say how long each of them should take. So now you know how we can add instrument by instrument and how we can create harmony. Because I believe you noticed that to write the exact notes, you're usually taking the most of the time. And for that, I prepared another example for you to show how even more sophisticated music may look and sound like. What do I have here so far? Bunch of notes. I have bass notes, bass times, and then with the concatenation, I'm making other notes. Melody notes, same for times, and bass notes, same for times. Then I have 4 different instruments, synth, bleep, mono, sine. I'm making from 2 different synthesizers with different parameters. And then I'm simply playing different melodies with different instruments. Keep an eye, I'm going to introduce the last element in Jibber, which are effects. that's all with Jibber. Thank you. Thank you. So now you know how can we use JavaScript to create music, to create that with live coding. But I promise to you that we will look into another way of using JavaScript. We will look into music creation into our web applications. And if we're looking into the history of audio possibility in the web, that is nothing new. We had different ways how we can do that. But today I want to talk about the most sophisticated way to do that nowadays, which is Web Audio API. And why it is so great? It's not that Web Audio API enables us to play or replay some audio track. Web Audio API enables us to create our own sounds, to analyze them and modify as well. So basically, it enables us to use browser as synthesizer. How does that work? If we have some web application, for that we would need to create audio context, and everything gonna happen there. We would store the audio state there. We would create our source. That can be your audio track. That can be oscillator as sine or simple microphone. And then we would need to connect that to the destination. Where do we want to output the sound? Usually that is speakers. If we would like to add some more modifications or analyzation, that would happen in the middle. But this is the general picture. How does that work? And I believe you want to ask me, Laura, how could we create our first beep sound simple from browser console? This is the answer. We would create the context. We would create the source. You see here, same sine oscillator which we had in Jibber. Then we simply connect that to the destination, and that's all. We would play it. Yes, that's a bit more writing than in Jibber, simple saying sine, but we do not need any special environment in Jibber. This is simple our browser console. And of course, there are an easier way to do that, because we developers, we love libraries, and there are libraries for that as well. One of them is Tone.js. If you're reading about Web Audio API in MDN documentation, you will see Tone.js as a suggestion to use it. How many of you use Tone.js so far? I have some great news for you. I'm going to show you the short demo. How can we do that? What do I have here so far? A simple Angular application. I just installed Tone, simple with npm install. So far I have the component instrument. So you can imagine, we will create our own instrument in the web. In the HTML, I'm just having a bunch of buttons. I'm iterating through the hard-coded notes. And whenever I click on the note, I'm just playing the note. I'm passing that exact on what I was clicked. And in TS file, I have those hard-coded values. And I have the element from Tone library. You see it, synth. I'm taking that from the Tone. And whenever I'm using that in a function, I'm simply triggering the exact note, which is coming from the HTML. How does that look? So we have the instrument which is able to play any melody, any sound we are playing, we do want to play. And it's amazing that only those few lines, we have full range of the instrument. But I think we can make something better. We can go better. And I thought that so far we're using only default sound. We need to change that. We need to have some unique taste. And I applied some modifications. Let's look into them. This is unique instrument, right? Katyana instrument. As you noticed, probably it's playing cat samples, but still according to the right pitch. And I was honestly surprised how easy that was to make with Tone.js. Because in my imagination, I thought that I would need to change every sample by myself and then maybe to map it with Tone help. But that was way easier than this. Let's look into the code. Nothing changed for the synth part, and in HTML as well, nothing changed. But now we have the sampler. Sampler as well coming from the Tone library. For sampler initialization, I need to provide what kind of sample, original sample, I want to play. So you see it here. And as well, I need to say what kind of note original cat was singing. That was tough, but it was G2 note. And that's all, nothing more was needed to provide. I simply just adjusted the volume because cat was singing very loudly, but nothing more was needed to provide. And that was amazing that Tone.js handled everything for me. And as you see in the function itself, I'm simply triggering the exact note together with the synth. And this is how we can have our own instrument. Now, some of you may think, cats sound instrument. How useful it is. But don't judge me too soon, because for those few of you, I went an extra mile, and I created something special, something different. This is the Guyana instrument, which plays dog samples, but still according the right note. But not only this. So this is the Guyana instrument. I do not want to overwhelm you with a lot of details, but I want just to show you a few things. Because there are many different elements in Tone.js which you can handle in different ways. And you can really cover many different cases. Let's start that there are different instruments, synthesizers. I used before synth. Now we have something as polysynth, and we can give different parameters. Before we were using always sine oscillator. Now you see there are another one, square. Going forward, important element part. And part may look a bit complex at the beginning, but it does nothing more than just plays predefined melodies with predefined instruments. You see, for example, here I'm using sampler, dog sampler, and polysynth instruments, two instruments, and I'm playing melody chords, predefined notes. Melody chords I'm taking, importing from the constant files. You see it here. I predefined every note. I wrote when it should play, how long it should play, and what kind of note. And when I'm playing the same few notes at the same time, this is how we are getting chords. Going further, as well, for part, we can describe, do we want that in loop, how long that loop should take, and so on. Then we have noise. Noise is as well another element in tone library. You see I'm taking ping, for example, but I'm not playing noise straightly. I'm adding some modifications, as here I'm adding filter, which is making some waving effect. And as well I'm adjusting volume, and then I'm only playing that. Back to basics, I am playing some audio tracks. You heard we had some audio tracks. And I'm taking randomly what kind, which one I want to play at that moment, whenever user clicks. And then I'm simply playing it. And the easiest thing, we can just increase tempo, for example. So there are different elements in Tone.js which you can use, and we can create different music, different sounds according to the user's actions. And usually when we are thinking about front-end development, our full focus is only on visual part. Sometimes we totally forget that we have audio possibility in the web. But please note that sometimes audio can really enrich our visual part. And in this way, we can really create the next level of user experience in the web. If you're thinking right now, Laura, I'd been tricked. I did not sign up for a front-end lecture today. Don't worry, because this, we're leaving JavaScript. We're leaving JavaScript and moving forward to a totally different programming language. The language which was specially created for music programming, Sonic Pi. Do we have Ruby developers here? You're gonna see some similarities because Sonic Pi is based on Ruby. And despite that, interestingly, despite that I'm a front-end developer, Sonic Pi was the language which introduced me music programming capabilities. And originally Sonic Pi was created for combination, to combine the lessons at school, to combine programming and music. But at the time it was improved so much that people started to use that for live coding performances. Let's look into Sonic Pi now. The first thing, Sonic Pi is coming together with the IDE, so you need to download that. And you already see the first beep sound program in that. Let's play it. I believe it's pretty easy to understand what is play. But what is 60 now? Is it still frequency? Yes, because no one changed the physics part so far. But we're using not in hertz, we're using MIDI keys here from the 0 to 127. On the other hand, we know that we don't need numbers. We can express that in letters. And we can do the same in Sonic Pi. We can simply say that it is C4 note. And we hear the same thing. Going further, we can add some options. And we can add, for example, change the amplitude. The default value here in Sonic Pi is 1. So let's have something more. And something less. It's still playing very quiet. Okay, going further, we know that to play only with one note, it's not efficient. And we can as well provide here the list of notes. Here we simply need to say that it is play pattern's time now. And I need to provide the list of those notes. And another list, as you know, we need to say how long each of the notes should take. Let's go further. We even can change the synthesizers. And in Sonic Pi, everything is synthesizer. For example, piano is synthesizer. Sine oscillator is synthesizer. Even noise is synthesizer. But that was still according to the notes. That was still C4 and G4. And there are other elements in Sonic Pi for which we even don't need to provide the notes. They are samples. There are different kinds of them. There are simple audio tracks which we can still modify, but no notes are needed to provide. We can simply change that. Change that. And we hear different sounds. On everything what I just mentioned, we can add effects. And effects in Sonic Pi, we are adding not on some melody or on some instrument, we are adding on everything what is inside do and block. So I'm adding here slicer. And let's have another. We hear the difference. So now we know how can we change the sounds. We can change the frequency, amplitudes, basics. We can add different synthesizers, change them. We can add samples, and on top of everything, we can add effects. But what about music evolution? Because so far, our music is finishing very, very fast. And we do not have the loops by default, the repetition which we had in Jibber. And here, in Sonic Pi, we don't have some hidden functionality. We don't have that by default. And that means we need to implement that explicitly. And there are different kinds of loops in Sonic Pi. Let's start with some fixed ones when we know how many times do we want to play that. For example, here, I will play this 2 times. But sometimes we don't know how many times you want to play that. That means we need to use infinite loops. And in music programming, we really want to have that because now our result is in the time and we want to have that as long as we wish. For that, let's use some infinite loop. And that will play until I manually stop it. And now we can start to think about some harmony. We have some melody playing as long as we wish, and let's have some drums playing as well. So now I'm creating another loop. I will use sample, drum sample. I want to play that every second. So every second I will have drums. And at this moment, is there anyone who do not believe that we will hear melody and drums playing together? 1 person, 2, 3. Okay, the moment of truth. We do not. because this is how a program works. It is executed instruction by instruction, and we are stuck in the third infinite loop. That means we need to implement concurrency explicitly as well, because we need to play melody and drums in parallel. And how can we do that? For that, there is different kind of loop. We need to say that this is live loop now, different kinds of loop. And for live loops creation, we need to say the name, the unique name. Because basically here we are creating different thread, and we need to have that unique. So here I'm having melody thread. Let's have here drums. Did you notice? Did you notice that I changed the instrument, simply ran the program, and without losing the beat, we heard the difference? Live loops not only enables us to play something in parallel, it enables us to change music on the fly, to change that during execution. So only now, actually, we are reaching the essence in Sonic Pi, and only now we can go to my last example today of live coding. What do I have here so far? I have a bunch of notes. I'm simply playing some Lithuanian folk song here. You're gonna hear that. And then I have the function which plays 4 different chords, and I can manipulate the sleep time and release time. Then I have the live loop for melody, live loop for chords and for drums, for recording, and I have some commented code as well. You're gonna hear and understand why. Okay, let's start. Thank you. Thank you. That's all from my side. Thanks a lot for coming here. It was my real pleasure to be here. Thank you.